Alright, so I'm limited on the screencasting program I'm using, so I'm gonna finish up this last little bit here. So we left off, we talked about gradualism and punctuated equilibrium, where evolution can animals can either adapt gradually, which is what we typically see, but there have been some recorded cases where punctuated equilibrium also happens. Some patterns of evolution. So one pattern of evolution is divergent evolution. And so this is where species that were once similar to their ancestor species become increasingly distinct, meaning that these are going to be examples where are thought to come from one ancestor, but over time have evolved into different species entirely. So this is where the species they diverge from one another or they become more different from one another. Some real life examples would be the red fox, like what we have around here, and the kit fox, which is what we find in like more desert or grassland areas. So they are thought to come from the same ancestor, okay, which is a type of like canine wolf or canine fox, okay. And so what has happened is as they've adapted to their surroundings, okay, the red wolf adapting to the deciduous forest, being able to blend in, thick fur coat to be able to stay warm during the winter while they hibernate, compared to this fox, which is comparatively smaller because they live in drier conditions with not as much water. They are not as big of animals. They are also more light colored to help regulate body temperature and to blend into those sandy surroundings. And then the last thing on the slide is adaptive radiation. We've talked about it a little bit in an article. Sorry, I've got a bird clock at home. Alright. Adaptive radiation. This is a type of divergent evolution where a founding species evolved into many species to fit a number of diverse habitats. So examples would include Darwin's finches, all came from one common species to adapt with their beak shape and their beak size depending on what they were eating. Okay, another type of example would have been the tortoises. That's an example of adaptive radiation. And then this is actually an example on the next slide. The second pattern of evolution is convergent evolution, and this is a pattern where distantly related or unrelated species evolve similar traits due to living in similar environments in different parts of the world. An example of this would be the sugar glider and the flying squirrel. So if you take a look at them, I'll go back to the last slide. If you take a look at them, they look very similar. However, they are not related to a common ancestor. Okay? Even though they look like they should, they've adapted to their surroundings and what they need to do, but they live in two totally different parts of the world. North America for the flying squirrel, Australia for the sugar glider. And what we see is that the flying squirrel is actually a mammal. Okay, so it gives birth to live babies. It does not have a pouch, similar to kind of the squirrels that we have around here. The sugar glider is actually a marsupial, meaning it gives birth to teeny tiny babies. Those teeny tiny babies crawl up into its pouch and develop there, much like you would think like a kangaroo or opossum would do. Okay, marsupials. Alright, so once again, they look like they should be related, but they're actually not. And so that's convergent, meaning that even though they are not related, they are adapting to look very similar. These two charts, I would make sure you know, look at them, make sure you understand them. Basically, with divergent evolution, we have something coming from a common ancestor, so here, okay, and then as those species start to adapt and speciation occurs, okay, especially if we have like disruptive selection, that's going to cause the species to diverge from one another. Okay, meaning over time, as time goes on, those species become more and more different. Convergent evolution is the opposite. So this is where we have two unrelated species, and as time goes on and as adaptations happen, those two very different species are starting to look more and more like each other. Okay, they look very similar. Divergent, convergent. Divergent, things are becoming more different. Convergent, They are becoming more common if you want some words to like associate with those. And then this word coevolution, this is when we have two species evolving in responses to changes in each other. So basically, this is seen when one species adapts. A lot of times, another species will have to adapt as well. So here's an example for you. The Darwin orchid has evolved long nectar tubes. So Darwin has his own flower. He's got his own volcano. What does he not have? I don't know. But the Darwin orchid has these long nectar tubes, and over time, these nectar tubes have gotten longer and longer and longer. Okay? Now, one of the reasons it's become longer is because it's able to keep more nectar in there. Also, it makes other insects get closer to the flower, allowing for cross-pollination to happen. Okay? So as that flower is adapting, there's another species that's also adapting because it's coevolution. This sphinx moth, which is one of the insects that drink the nectar from this particular type of orchid, has actually adapted to having these really long mouth parts called a proboscis. And what we see is over time, this proboscis, this mouth part, has gotten longer and longer as the flower's gotten longer. That's because those who had longer proboscis to begin with, okay, were able to get that nectar, pass on those traits, and the species in it as a whole has actually adapted to this. So coevolution, one thing changes, which forces another thing to adapt and change with it. And that is the end. If you have any questions whatsoever, please send me an email. Okay, I'll be more than happy to respond back to you. I'll be on my email pretty much all day on Monday, and then most of the day on Tuesday. On Tuesday I have a video meeting, a staff meeting or a video chat at 1 o'clock, so I won't be available from 1 to 2 on Tuesday, but the rest of the time I'm pretty much free. Please email me if you have any questions, and other than that, I hope you're doing well, guys.